Today we will discuss about graphical presentation of frequency distribution. In yesterday's class, in previous class, we ended with the diagrams. As I said, initially we started with diagrams. In case of diagrams, there are different kinds of diagrams are there. That is one-dimensional diagram, two-dimensional diagrams, then three-dimensional diagrams. Then comes the pictograms and cartograms. But when we discussed about types of diagrams, according to your syllabus, I have told that according to your syllabus, you are going to study only one-dimensional and two-dimensional diagrams. And in case of one-dimensional diagrams, further one-dimensional diagrams we divide into four categories. That is simple bar diagram, then multiple bar diagram, then comes subdivided or component, then last one percentage bar diagram. This comes under one-dimensional diagrams. We studied simple bar diagram, multiple bar diagram, subdivided and percentage bar diagram. Then we move towards the two-dimensional diagrams where two dimensions are considered, that is length as well as width. There we have, in case of two dimensionals, there are variety of two dimensions, that is squares, rectangles, circles, then pie diagram. But again here we are going to study only about pie diagram according to your syllabus. So we have seen pie diagrams, and in last session also we discussed about pie diagrams, and these three we are not discussing here, but we know that these are two-dimensional diagrams. So till now we completed the diagrams. We have seen the diagrams. Now we are moving towards the graphs, preparation of graphs for frequency distribution. Now the main difference between graphs and diagram we are drawing on the plain paper, but in the sense any other normal paper, but graph we are drawing on the graph sheet. We require the graph sheet in order to draw graphs. Now here graphical presentation of frequency distribution. What is that frequency distribution? Frequency distribution is nothing but what we have written here. These are frequency distribution. So, how to present this frequency distribution in the form of graph? And there are many ways are there to present the frequency distribution in the form of graph. In there comes the first one, histogram. Then comes frequency polygon, then frequency curve, and last one ogives. This you might have studied, some of you have studied in your text ogives. So these four we are going to study. These four this represents the frequency distribution in the form of graph. So these we are going to study. Firstly histogram we will see, then frequency polygon, frequency curve, ogives. These four are graph to represent the frequency distribution. How to present the frequency distribution in the form of graph. Which are the different kinds of graphs which we use to represent frequency distribution? It's a 2-mark question. Which are the graphs? These four are the graphs. Now in these four we are going to study all these four kinds, but firstly we will move towards the histogram. What is that histogram and how to represent frequency distribution by using histogram? There comes first one, histogram. Now the main here histogram is constructed for continuous frequency distribution. Histogram is constructed for continuous frequency distribution. These are called as continuous frequency distribution. And here height is drawn according to the class frequency. Height is drawn according to the class frequency and width is according to the width of the class intervals. And how this histogram will be? It's a set of adjacent rectangular bars. It's a set of adjacent rectangular bars. It's a adjacent rectangular bars whose height is according to the class frequency of that particular class and width is according to the width of the class intervals. So histogram is constructed for continuous frequency distribution and where whose height is according to the class frequency and width is according to the width of the class intervals. And it's a adjacent rectangular bars. Histogram is a adjacent rectangular bars. Write a note on histogram. Histogram is constructed for continuous frequency distribution and it's a adjacent rectangular bars whose height is according to the class frequency and width is according to the width of the class intervals. And here along the x-axis we represent the class intervals and along the y-axis we represent the frequency. And we consider scale for even x-axis as well as y-axis. So it is drawn in the graph shape. You have to practice in a graph shape. If you draw it in the plain paper, it is wrong. Graphs are always drawn on the graph shape. Now we draw histogram for these two frequency distribution. We'll see how to draw the histogram. We'll take the first one. See that first frequency distribution. Draw a histogram for the following. Directly they have not mentioned whether it is number of marks or number of students. Nothing they have given. Directly they have given class intervals and frequency. Now firstly we'll write the heading there. Histogram of frequency distribution. Since they have not given anything, so we take it as histogram of frequency distribution. If they give histogram of, for example, marks, histogram of marks obtained by a particular class or student. Now draw their x-axis and y-axis. X-axis and y-axis. Along the x-axis we represent their class intervals. Here. Then here we represent frequencies. This is y-axis and it is x-axis. Now represent the class interval. Scale you need to take. See here, if I take 1 centimeter, it will be very small. I will take on an approximate basis. So you have to take there 1 centimeter scale. There write the class intervals. Here it is 0, 10, 0 to 10, 20, 30. 30, 40, 30, 50. Till 50. One extra bit axis. Now here, along the y-axis, see there, which is the highest number? Highest number is 15, smallest is 10. Okay. Will move 2, 4, 6, 8, 10, 12, 14, 16, 16, then here it is 18. Till 18 will move. Write once again. 2, 4, 6, 8, 10, 12, 14, 16 and 18. Now see the frequency distribution table there. Then first one, before that write the scale here. Right here, scale x-axis is equal to 1 centimeter. 1 centimeter, what we have taken? 10 units. Y-axis is equal to 1 centimeter. What is that? 2 units. The gap of 2. This is the scale, 2 units. Now, see here, 0 to 10, that is 13. 0 to 10, where 13 comes? 0 to 10, it is 13. 13 means it is 30. 0 to 10. Next comes 10 to 20, 17. 10 to 20, 17. Okay, 17 is here. 10 to 20. It is 17. 10 to 20, 17. Then 20 to 30, 15. 20 to 30, 15 will be here. 20 to 30, 15. 30, it is 15. Then 30 to 40, 13. 13 will be here. First one, sorry, see there. First one, it is up to 13. Next, here also it is 13, 30 to 40. Then comes it 30 to 40, 13, and 40 to 50, 10. 40 to 50, there it is 10. 50, it is 10. So this is a histogram. No need to shade anything. No need to write index anything. So this is about histogram. Here class intervals. Then see the frequency. According to that you have to mark rectangular, adjacent rectangular bars. Don't forget to write the scale here, and here class intervals, frequencies and graph heading. 1 centimeter this side, and here also 1 centimeter. What is this? This is histogram. Now we can see there one more problem is there. One more frequency distribution they have given. Now we move towards the next problem. The first one, I hope you don't have any kind of confusion. This is about histogram for class intervals. Here you need to get continuous class intervals. Then 0 to 10, 13 and 10 to 20, it is 17, 20 to 30, then it is 15, then 30 to 40, it is again it is 13, 40 to 50, it is 10, 40 to 50, it is 10, 10, I think it will come here, it's okay. Now we'll move towards another frequency distribution. Now, if you see the second frequency distribution, there is difference between first and second frequency distribution. First one, see the class intervals, it's of exclusive type. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. But here it is not continuous. 2 to 4, 5 to 7. It's in inclusive form. Here, draw histogram for the following data and locate the mode. One more additional question is there, that locate the mode. We can locate mode from histogram and also we can locate medium from OGs. Now we can locate mode from histogram. So see here wages and number of workers. It's in inclusive form. So we cannot draw histogram when frequency distributions will be in inclusive form. We have to convert into exclusive form. How to convert inclusive form into exclusive form? How to convert a frequency distribution inclusive into exclusive? As I said, we use the formula of correction factor. What is the formula of correction factor? So here, correction factor is equal to lower limit of second class minus upper limit of first class divided by 2. Now, lower limit of the first class. We use correction factor to convert inclusive class into exclusive form. Now here, correction factor is equal to lower limit of the second class. Which is the second? This is the first class, second class, third class, fourth class, fifth class, sixth class, seventh class. Lower limit of the second class. Formula will not change, it will remain as it is. Which is the lower limit of the second class? 5 is the lower limit of the second class minus upper limit of the first class. Which is the upper limit of the first class? 4 is the upper limit of the first class divided by 2. What do you get? 1 by 2, that is 0.5. It's not necessary to calculate, it's always 0.5. So how to convert this exclusive form into inclusive form into exclusive form? Now, right there, wages, number of workers. Wages now, what we need to do? We got correction factor at 0.5. We always, when we convert inclusive into exclusive, deduct 0.5 from the lower limit and add 0.5 to the upper limit. Then continue. Here also, deduct 0.5 from 5, add 0.5 to 7. Now start with first one. Deduct 0.5 from 2. There will be 1.5 to add 0.5 to 4. 4, 5. First one. Next one. Deduct 0.5 from 5. 4.5 to add 0.5 to 7. 7.5. 7.5. Same thing, continue. Deduct from 8. Deduct 0.5 from 8. 7.5 to 10.5. Next one. 10.5 to 13.5. The next one. 13.5 to 16.5. Next one. 1.5 to 4.5, 4.5 to 7.5, 7.5 to 10. Then what is the number of workers? That is 2, 6, 8, 25, 40, 30 and 20. This is one exclusive form and inclusive. Even your frequency distribution will be in the inclusive form. You have to convert into exclusive form. What you need to do? Deduct 0.5 from the lower limit, add 0.5 to the upper limit. Deduct 0.5 to the lower limit, add 0.5 to the upper limit. Then you will get in a continuous form. Here it is not in the continuous form. 2 to 4. It's not 4 to 7 again. 5 to 7, 8 to 10. So now we can draw histogram. Now locate X and I erase this problem. From here we can draw. As I said, that one more question is there. Locate, hence locate histogram. Now X axis and Y axis. Here it is. Axis and here it is x-axis. It's about what? Histogram of wages. Wages of number of workers. Now here what we need to locate? Here we need to locate wages, that is nothing but which will be in the class intervals form. Now here number of workers. Number of workers. Now locate their wages. Here it is 0, 1.5, 4.5, then 7.5, then 10.5, then comes 13.5, then 16.5, 19.5, and then last one 22.5. Last one there 22.5. 22.5. This is x-axis. Now, locate the number of workers. Which is the highest number there? 40. Which is the lowest number? Lowest is 2. So, it is better to go here from 5, 10, 15, 20, 25, 30, 35, 40, 45. 1. Write the scale. X-axis is equal to 1 centimeter is equal to wages here. What gap we have taken, that we need to write. Then Y-axis is equal to 1 centimeter. Then that is 5 number of workers. Now we will locate the values 1.5 to 4.5. So immediately 0 to 1.5 it's not given. 1.5 to 4.5, what is the value? Value is 2 there. 1.5 to 4.5, value is 2 here. This is the first one. Next it is 4.5 to 7.5, 6. 4.5 to 7.5, here comes 6 just above value 5. Just above the value 5. Next comes there 7.5 to 10.5, that is 8. 7.5 to 10.5, there it is 8. Next comes 10.5 to 13.5, 25. It is 25. It is 25. 25. Next 13.5 to 16.5 is 40. 40, here comes 40. Here comes 40 to 16.5. There we get 40. Next comes there 16.5 to 19.5, that is 30. 30 comes here. There it is 30. Then last one 19.5 to 22.5, that is 20. There we get 20. Now this is histogram. We presented the histogram. Here 1.5 to 4.5 to 4.5 to 7.5, 7.5 to 10.5. Directly what class intervals they have given, that you are representing here. If it is in the inclusive form, we have to convert it to exclusive form so that we get their continuity. Then the frequencies you have to represent. Here it is number of workers. Now how to locate mode? They have told locate mode there. Now locate mode means you have to see which is the highest, which of the which bar's length is the highest. So this is the bar which has highest length. From that bar, from this corner to opposite corner, this corner to opposite rectangular bar's corner, from here to once again opposite rectangular bar's corner. Now where these two lines intersect each other, that point, here you have to draw one straight line. Here if it is 13.5, approximately we can take it as 14 or it is 15. Here it is 15 or 14.5 or 15. So here z is equal, what value you will get, you can get easily, you will properly exact value you will get in case of graph. If you do it in the graph sheet, here we can take it as 14.5. It will fall in between 13.5 to 16.5. It may be 14.5 or 15. It may be 14.5. We take it 15. We may get here 15. So this is the way of locating mode. See there which bar's length is the highest. They from this corner to opposite rectangular bar's corner, from this corner to opposite rectangular bar's corner, you have to draw lines. Where these two lines intersect each other, from there to vertical line towards the x-axis. That point, in that point, what value you will get? That is the value of mode. And here one more question. From which graph you can locate mode? We can locate mode from histogram. Remember, we can locate mode from histogram and medium from ogive. That we have to see. We have to see that. We'll see that. So this is about histogram. Now we'll see some other problems under histogram and some other types of graphs also we'll see in the further classes. For today's class, I'll wind up with this.